So we have the full stack deep learning course that we talked last week. That some guys were interested to do that one, so we can talk on how to do it. And then Mehul could talk about the how to start with Kaggle. And also, I think that's within the Kaggle presentation, Mehul is going to show his object detection part. Is that right, Mehul?
Yes.
Excellent, excellent. So are we going to start with the full stack thing, or we start with Kaggle? What's the kind of preference?
For me, you can start with full stack, maybe.
Yeah. Okay. So because we finished the part 2 meetups, and last week there was an idea we could go into another course which is called the full stack deep learning, which has got 15 lectures. So today I was working on how we can split those 15 lectures into our meetups, and initially I put like 1 lecture per meetup. But then we had some more discussion with some other guys, and looks like they are not that heavy, so as the Fast.ai, so we could maybe take more lectures into 1 meetup. So this is what I kind of I'm suggesting. So before I go into that, I can show the web. Yeah. So this is the course page. Yep. So this is the kind of bootcamp that was released sometime in March, I believe, and it's freely available on that page. So they had this own bootcamp, and then they made the lectures available online. So what they talk about, so they present this picture here that's on the first page, that you have some courses that teach you theory about deep learning, the math behind it, computer science behind it. Then on top of that, you have trainings that take this knowledge further and talk. This is like the Fast.ai course or the Deep Learning AI course or Keras. This is about how you can train models. But the next thing that's kind of missing in all those courses is how you deploy, how you ship your deep learning projects. So this is what this bootcamp is all about. And they use a project throughout that bootcamp in 4 lab sessions, where they use the text recognizer app as an example. And they took this bootcamp in 2 days, and in total they have 15 lectures. So if you go on here, for each lecture you have a video, and also for that lecture that there are slides, there will be slides, so you can open as also slides. Yep. So we have videos, we have slides for each lecture, which is cool, I think. And also we have the GitHub repo for this project. So we have some instructions on how to use the code and how to build that text recognizer app. Although I didn't do it myself yet, so it's not that clear to me whether this is going to work without being in the bootcamp, but at least we should give it a try, especially the first session. It's more like an introduction to that lab and talking about the eMNIST dataset, which is like the MNIST dataset, but talks about the lines of the code, I think. So I think we have quite a lot of material available, and hopefully we can try to use it as a MOOC, which wasn't, I guess, designed to be a MOOC by these guys, but seems to be everything is in place to kind of do it. So since it was suggested that going lecture by week is kind of like not enough, maybe, because for example, this lesson is like only 26 minutes of video. So maybe we could do more than that. So I've kind of suggested, I looked into how much time it takes for each lecture. So like lecture 1 is 26 minutes, and then lecture 2 is like 1 hour, and lecture 3 is actually the lab. So the green ones are lectures, then this violet one is lab, and then again we have lectures, and then we have some also guest lectures, which is not in the main course as such. So I would say they're optional. And Jeremy Howard, by the way, is also a guest lecturer there. So in total, we have 14, almost 15 hours of video lectures. Out of those 15 hours, 9 hours is the lectures, and the lab is about 2 hours. Although that's a little bit strange, because if I go to that GitHub, they show that the labs in total should take more time than 2 hours. So like the first session was scheduled for like 90 minutes, the second session an hour, the third session 1 hour 30 minutes, and the last session like 75 minutes. So there's a little bit of a misalignment in the time the videos take of the labs. But I tried to take that into account where I was setting up how many lectures we could take per week. So that's what I'm suggesting, to kind of to go in that pace. So like the first week, I'm kind of suggesting to watch the intro and the second lecture, and also give it a go with the lab. And then the week after that, there's video on the infrastructure and tooling, and there's corresponding labs to that, the labs 4 and 5. And also, because that only takes a couple of hours, we can add another lecture to that on data management. And then we can move on to week 3, which will be one lecture, one guest lecture, and troubleshooting lecture. And then because the other labs is lab 6, 7, 8, and 9, I suggest we split them, and then we do, in week 3, we do lecture 11 as labs 6 and 7, and then week 4, we do 8 and 9. And also in that week 4, we finish with the last 2 lectures, and then again the guest lectures as optional. So if we do that thing, then we potentially could finish that within 4 weeks. Do you guys have any thoughts about that, or comments or changes to that schedule? Is anyone in the meetup interested to do this course at all, or we should do something else instead? Or maybe someone will have some comments in the chat. Let me have a look in the chat. If I can, okay, I can see here some comments. So there's a comment about pasting the link. I'm not able, okay, yeah. So the link is there. So we have like interested, seems like a plan. Okay. What all options we have, like other courses? Yeah, it's a good question. I'm not sure. I think there are lots of different courses available, and most of them are also, a lot of them are free courses. So it's up to us to make that decision what to do next. Yeah, it's all an open question. Mm-hmm. There is also a link to another full stack deep learning tools. Let me open that link.
Yeah, so this is Yuri. So I this is the only blog I found that from somebody who actually took the class this March.
Oh, great.
So it was interesting. It was sort of summary of the lessons, but
yeah. So it's like we
not,
have like
I didn't find anything like specific like out that I saw outside of the lectures, but it's written as one page, so it's a good summary.
Yeah, yeah. Oh, excellent. I'm going to add that to this file. So there's a lot of links here available. So this is like.
So as far as I understand, if we're doing this class and we keep the project open, we should be able to use weights and biases, right? Because it's free for open source projects.
Yeah, I think so. So I've created an account there at Weights and Biases.
Mm-hmm.
How does it look? So the Weights and Biases, it's online tool that you could use to monitor your trading, and I believe you're right. It's free. So I'm still not fully sure how to use that code though. I think it should be possible because it's like almost everything is there. So I believe that's my take. If we follow the videos, we should be able to use the code with one exception, that for that bootcamp they had some sort of code that you could paste into the weights and biases page, and that would open the Jupyter notebooks with GPUs. So we don't have that code. And so for that, we need to kind of we need to open the Jupyter notebooks in whatever way we do it, like either Colab or locally or whatever GPU cloud, and then connect those notebooks to the weights and biases. So there's like a callback, and I think they explain on the website how to do it. Yeah, there should be an explanation. There should be docs somewhere here. Yeah, they have documentation page, and they basically tell you how to do it. Like there's an example in PyTorch. Well, that will be part of the kind of the thing that we're going to discuss in the. I didn't go through the labs yet, so I'm not fully sure myself how to do it. But there should be a way to put some code in your PyTorch code, and that will be in the form of callbacks, and that would log all your results, like your loss and your accuracy, to the weights and biases API, and then you can see on the nice graphs how you're performing. So that's the thing. So I hope so. I hope we can do it. So the way I organized those lessons were around the labs sessions. So they have 4 lab sessions. So this is what I thought would be our kind of good division of what we should review each week. So like the first session, I thought that would be something we could review on the first meetup, and all the like video lectures around that session. And then second session for a second week, third session for the third week, and the fourth session for the last week. So I thought that would be kind of a way to do it. So in this way, we could see if that's enough time or not. Let me see if I can.
They just shoot it. They just shoot. You see them now with official. They don't shoot you. Just as if we don't know you. That's how that shot. Can't we have some? This is what's called school. Not school. All of you went to you were growing up. It was called school.
I'm not sure now how to. Where are my controls? Oh, it's here. Okay. So I want to more post, optimize search, more manage participants. It's here. So I'm going to mute all, and then so if you want to talk, just unmute yourself. Okay. Good. All right. Right. So let me see what's else on the chat. Okay. Right. There is another suggestion doing the ML course AI. That's, of course, another option and another good course as well. And I believe the ML course AI, you have to do it kind of, can you do it on your own pace, or do you have to start, like, so it starts September 2nd, right? So the next and final session launches on September 2nd. And that's more, I think, on machine learning, though, but I think it's a very good course. It's based on Kaggle a lot, and they've been running this for a long time, and this, they had one session this spring, and then this fall, starting September, that's going to be the last session they do. I don't know what sort of plans they have for future. Maybe they're going to change the different course, or maybe they want to start commercial product. But I think that's also a very good course. So we could start September 2nd as well. Why not? We have time. Let me see if there's anything more. That's my understanding, at least. Tell me if I'm wrong. Maybe we can do it now. I'm not sure. Right. Right. As far as I'm aware, the ML course.ai, it's not really like full stack, and it's more on machine learning, but it's based on Kaggle. So it takes Kaggle competitions as your homework. So this is the kind of similar way as other Kaggle competitions. It's not really full stack. You take the data from Kaggle, you analyze the data, and you submit your results to Kaggle. So this is this kind of way. What is weights and biases? I thought I explained that. Tell me if I didn't. Yeah. So I think that's right. So I think the best way to do it will be to watch the videos and try to do the labs, and then when we meet, we can talk about what was easy, what was difficult, what's good, we could share our experiences, how it worked. Yeah. I'm still going through the chat. There is still some discussion there. Right, so I think some comments regarding ML course that you can do it anytime you want. I think what's nice if you go with the like September 2nd is that you can take part in the they create like a leaderboard list. You get so many points for each assignment, and you can pretty much participate with other participants on that. So that kind of makes sense. And also they have like Slack for that course when they talk about this. But yeah, it's up to us. We can do it. It's fine. Yeah. And then there's a question whether we should create a new channel for the full stack course. That's also possible. Why not? So seems like majority said that the full stack course seems good for now. So maybe we should give it a go for now, and then later we can think about what to do next with. Yeah, so we could September 2nd. That's somewhere here. We could do that, or yeah, a lot of options. So we can do a lot. Okay, well, seems like we aligned. So let's do the full stack. And so for next week, we go with the, so if between now and next week we watch lecture 1, 2, and 3, and give it a go at the lab, the first session of the lab. So if you go to the course page, lecture 1 is actually introduction. So they talk about the course. Lecture 2 is like an hour, and they talk about projects in machine learning. And the lecture 3 is the lecture that talks about the intro to the lab. And that lab you can find here, which again is the overview of that lab, introduction to the data set, an overview of the model architecture. So I believe the first assignments for us shouldn't be that difficult. So let's see how this goes. And yeah, let's talk about this next week then. Fantastic. Are there any questions, or before we move on to another presentation? If there are no questions, we could proceed to presentation on how to start with Kaggle. If Mehul is still with us.
Yeah, I'm here.
Okay. Do you want to share your screen, Mehul?
Okay. Yeah.
I will stop sharing my screen. I'm going to monitor the chat so you can present.
Okay.
Thank you. So I'm going to stop sharing my screen.
And if I share a, okay, I got it. Yeah. Okay, do you see my page? Do you see my screen?
Yeah, we can see it.
Okay, see the screen.
Okay, so yeah, in the last session there was a request for like getting started with Kaggle. So I've been doing Kaggle like for 2 years.
Mehul, sorry about that. There's some comments that we have some the volume of the sound is not that good. Is there any way you can try?
Is that better?
That's a little bit better.
Okay. Let me see. Now?
Yeah, I think that's better. Thank you.
So I've been doing Kaggle seriously for the last 2 years now, and so I can tell you my experiences and how I'm using it to learn new machine learning techniques and stay up to date. Okay. So there are 3 main parts. So there is competitions, well, 4, yeah, competitions, data sets, kernels, and learn. So Kaggle learn is something new they started this year. And do you now see the the Kaggle Learn link? I just want to make sure when I open a new tab, it shows you that. Yes. Okay.
Yes, we can see it. Yes.
Okay. Yeah. So the I think Kaggle initially Kaggle was a startup here in the Bay Area, and then they got bought by Google like 2 years ago, and since then we see they have more resources. So for example, Kaggle Learn is something new that's come up in I think the last year. Um, so there are it's basically short micro courses. Okay, so like there's something for Python, data visualization, pandas. Um, I really like it because it's a very short and a quick intro to the area. For example, I haven't done much SQL, so but I needed to fetch data from my company databases or somewhere. I need to know some SQL, so you can click on that and get um, get a quick introduction to SQL. There are also some there will be lessons, and there are first there are some short lessons, and then there is an exercise to test your skills. And most of the material has been really good. Um, I found this. I've done SQL and I've done some part of pandas. Yeah. Okay, so that's one of the new things in Kaggle that's really good. Like to get a quick introduction, and everything is in one place here. Okay, so that was Kaggle Learn. Um, the other really nice part is something called Kernels. Okay, um, so initially Kaggle started as competitions only. So there would be like some data science competition. They Can you predict house prices, right? This is the training data set, and can you predict house prices? Or I have this data set of uh, things of the sales of last year. Can you predict what will be sold? Um, let's say, um, like what is the future sales for various products? Okay, so Kaggle has been around for a while. Let's say I think Jeremy Howard was the chief technical officer there, and if you see his profile, he will say that he was the um, I think he was the competition's rank 1 for like 2 years. I think 2011, 2012. Right? Okay. Um, so initially the community was very small, and since then it's been and it's just exploded. So one of the really nice thing is um, people share their kernels, and so what is a kernel, right? Let me just show you one example. How do I move? Shoot. So it will be it is basically like a Jupyter notebook, okay, and where somebody has done a really good job with, say, uh, exploratory data analysis. So they show you, okay, you have a data set. What's the best way to, not the best way, but okay, here's what was their approach to do exploratory data analysis and display the various things. So for example, here they use pandas and seaborn, and I basically learned about seaborn from the kernels, right? That's where I learned it. And mostly people put a lot of effort into kernels, and I'll tell you why. There are two very interesting reasons. They The first one is they have a monthly prize of $500. So if your kernel gets a lot of votes, you win $500. So people are quite motivated. And I think they even increased it to $1,000 or $2,000. So you can see here someone has put a lot of effort to like write a really good notebook with for example exploratory data analysis, how to work with the data, and then basically try out pretty much everything um, in a very popular machine learning package, scikit-learn. Try out all the different methods, and most of the times I find yeah, and of course you can go there and you will get the details. So elastic net is a powerful machine learning technique, and if you just want to quickly see how to use it, you can you have the example of how to use elastic net. um, it has many parameters. So scikit-learn has an option called grid search. So um, it shows you how to use these commands. So my point is, I will come here, I will look at the kernels, and most of the times I'll be like, oh, for example, I did not know scikit-learn has grid search. And this is really a great feature, because many times you have models but you don't know how to select parameters for your models. So and pretty much everybody who's doing machine learning has the same problem, right? So from this kernel, you have a nice way to see an example and then try it out on your own. Okay, let me minimize this. Um, and if there's any questions, just stop me. So once the other nice thing is, okay, you have this kernel, right? And right now you're just reading the code, right? But like Jeremy says, the best thing is just type it on your own and play with it, change things around. So for example, I want to change these parameters. Okay, I want to play with these things, try out different things, see what works, what doesn't work. So you see on the upper right, there's this button fork, and the number indicates how many people have made a fork of the script, and this is just how many upvotes this particular kernel got. Okay. Any question? So I'm going to go ahead and fork it. But any questions so far?
I think it's a good explanation.
I have a it's more of actually it's kind of a question. Yeah. So why is it called kernel? I mean, can we translate it just with the methods and the code that they used, or I'm wondering why the specific name kernel?
Yeah, that's a good question. I think they could have just called it notebooks.
Okay.
Yeah, somehow it just came up. Yeah.
It's just the name, I guess.
Yeah.
It's like the Google Colapse notebooks, or because Kaggle is owned by Google, so it's a Google company now for a number of years. So they kind of they're not really competing as such, but kind of, because they also offer free in those kernel notebooks. They offer free GPUs. I think at the moment P100, right?
Right, and and that's the thing. I think even before Google bought them, they had the kernels, and that time the GPUs were not so good. And since Google has bought them, they've been improving a lot. Actually, one of my friends from my graduate school works there, so that's how I know some more stuff. She's been there like 4 or 5 years.
The kind of difference between Kaggle kernels and Google Colab is not so much, but a little bit. So the look of the notebooks is a bit different. But so like the Kaggle kernels, they have now GPUs P100, I believe, and you can run them for 9 hours and then they will stop. Whereas Colab, you can run them for 12 hours. And now the strongest GPU you can choose is like Tesla T4, so I think that's a bit better. With the Colabs, you have to get some data storage. So like you can link your G drive, which you have like 15 gigabyte free storage with that. With Kaggle kernels, you get a bit more. You can get your own data set uploaded to Kaggle, and it's like 100 gigabytes. So there are a couple differences between those two services, but they are very similar. However, there are some differences between them. Yeah.
So I have a question on forking the kernel. So what happened to me before, I tried to use different people's solutions, and I think I accidentally published my kernel. Do you know a good technique to like stop yourself from publishing?
So when you fork it, by default, the kernel is private. Okay. So you have to. I think let's see here, right? Let's see it live. I think you have to take a few steps to make it public. So for example, like last week when I spoke, my kernel was private and I made it public for the group. Let me see if I can find it. Let's see. Yeah, you need to commit your code. So first step was fork, then commit.
Yeah. So just comment there. So if you commit the code that's going to run 9 hours, you're going to wait 9 hours.
That's true.
So there's a warning there that if you fork the kernel and it's in draft, you can still run line by line. It's fine. You can work with it. So because it's got this version control that also controls your data. So when you hit commit, it's going to save your input data. It's going to save your code. It's going to execute the code from top to bottom. It's going to save all the output files, and it's going to save all of that as a one commit version. So I think it's really good because you get everything you need to replicate the results. You have the data, you have the code, and you have the output. What's not so nice about it is sometimes if you have like deep neural network, which takes like nine hours, you're going to wait 9 hours to commit that code. So sometimes you need to take that into account.
Right. Yeah, that's a good point. Yeah, thanks for. Yeah, so right now I committed it, so it's running. But let me just stop it so I can show you the line by line. Yeah, so here we just run this section of code, and then you can always add a code cell, add markdown, and try out different things that you might want to try out. Okay. I don't remember. I've never found like on the notebooks I use shortcuts. I don't know if Mikhail, if you know the shortcuts here. That's one thing. It's one irritating thing. Like I have to use my mouse. I would rather use keyboard shortcuts. Yeah, and you can see that. Yeah, that it's run. That box of code is run, and I really find this useful for trying out. Just understanding the code and seeing like how they did it. Sometimes I'll try and write the function myself and then just compare it to see. And most of the times I'll learn something new. I'll be like, oh, okay, they probably, because normally people who are writing kernels, especially if it's a high voted kernel, they have a lot of experience, and most of the times I learn something from the kernels. Right? One other thing that Mikhail said is, so you see here, you have all your data. So with the kernels, you have the workspace, right? So you see it here on the right hand side. There's an input folder, and in this case, you have the test data, train data, and the data description. Okay, so we are basically just reading it as a pandas data frame. Yeah. Okay. See, this is one thing I wish I know the keyboard shortcut, so I can just I don't have to work so much with the mouse. Yeah. And okay, do I want to say? Yeah, okay, I need to run all the cells up to here. So basically here you get this error because I haven't run all the cells above it. Right? Okay, you can also now, suppose you wanted to add your own data set, there are options for that, whether it's a CSV file, um, you can upload your own data set, or you can use some public data sets. So there is heart disease from University of California, and there are some labels like whether it's a classification or a regression data set. Setting. How do I change the settings? I was trying to. Yeah. So see, by the earlier question about making the kernel public or private, so by default it's private, and only if you make it public and then you make it public and save, and also so if you made it public by mistake, you can just go back and make it private again. Yeah.
Thank you.
Yep. So some um, interesting things. So for example, um, okay, maybe I'll talk about competitions and then come back to kernels and object detection. So there are okay. So we talked about Learn, Kaggle competition, Kaggle kernels, and you can fork a kernel and then try it out. And then the third thing is about competitions. So there are various competitions. So some of them are active competitions. Um, So sometimes I just enter it because I want to listen to the discussion, and I will talk a little bit more about why the discussion is so great. So there are active competitions, and there are already. Um, so these are showing like I entered 6 or 7 of them, and there are maybe 13 other competitions that are active. There are 2 types of competitions. So sometimes it's normally a company who's hosting the competition, and they will have a prize money of say anywhere from 10,000 to 100,000. Um, and then there are knowledge competitions where it's just you're just getting started. You want to learn digit recognition. So you can try the knowledge competitions. Um, you can see what other people are doing. So for example, if you go to um, digit recognition. Um, so you can think like each competition has its own sets of notebooks. Okay. Um, so for example, when I was getting started with Keras about 2-3 years ago, I would go here and just look at, okay, how to do convolutional neural networks in Keras, right? And I will I'll find a matching I'll find a competition that has, what I'm interested in. So for example, I'm not interested in digits. I'm interested in actually, say, animals, but I'm going to classify animals. So I just go here, get the kernel, and find the kernel which has the highest rating and or highest upvotes, and then just walk through it. Okay. So from here, I remember I was doing writing TensorFlow code, and then I'm like, oh, Keras is just much easier. So I learned most of my Keras from these kernels. It has pretty much you know everything you need to get a fully functional pipeline, like loading data, preparing the data, making the model. Um, okay. Yeah, so I remember, yeah, like for example, initially, so that's where so that's the Keras data uh, data augmentation. Okay, so every competition has its own set of kernels, and the other nice thing is you can uh, so you can join a competition, right? And let's say you write your own code, right? You can make the kernel, you can run the kernel, generate the output, and then you can submit predictions. Okay, so so for this, you have to follow the rules, and there will be some discussion about, okay, what is the format the output needs to be in. So those kinds of things they vary from competition to competition, but here it's like your submission should be in a CSV format, and there will be some rules about okay, what to submit. Okay. So normally when you do a competition, you want to let's say, okay, that's not so good. Yeah, you get a couple of things. Like, okay, so what the competition is about. So here it's about just classifying digits. Um, there will be some, mostly they'll give you some tutorial. Well, this is a learning competition, so there are a number of nice tutorials. So you see, like, okay, you can do it with deep neural networks, or just a convolutional neural network, or maybe you are more familiar with R, so you can try and do it with R. Okay, this competition, and I think one of the interesting things is okay to understand is, okay, what's the metric? So how is this competition going to be judged? So you will have, of course, you have your train set, test set, and you will have some metric, right? Saying, okay, in this case, it's just accuracy, but different competitions will have different metrics. Let me show you. So the biggest competitions, oh, and this is one really nice thing. Let's say, so there are 316 competitions that finished, right? And mostly whatever you're interested in, you will find some sort of example here. Let's say a competition is over, you can still make submissions to the competition. So it's called a late submission. So say you are learning right now, and you can make late submissions and see how your model does. Let me show you one more, one of the biggest competitions. So the biggest competitions are they're called the data science bowls. So yeah. So this one was um, in 2018. It's mostly these data science bowls are like 100K, and I think maybe before I've seen it bigger. Like, I think once I've seen a price of 1 million. Yeah, I think many companies are doing it is because if they have a hard problem, like, they will get so many solutions here. It's easier for the companies to do it this way. Then, yeah. Um, so this competition was segmenting cells. Okay. And again, you have the same pattern I described earlier. That is, you have an evaluation metric. So in this case, we were interested for looking. You have the ground truth segmentation of cells done by humans, and you will have the output of your algorithm, right? So in this case, the metric was intersection over union. So A and B are binary images. So it's A intersection B divided by A union B. Right? So if you had a perfect segmentation, if you had perfect output, you have an IOU of 1 um, or not. Okay, and there will be some details about how the metric, what is the metric they're using. So one of the things we always say before starting the competition is understand the metric completely. Like, okay, this, and different competitions will of course have different metrics. um, yeah. So one thing I start noticing is, like, people make really good kernels and sharing it. So there are two reasons. So one is, I told you, like, there is a um, prize money, but there is also in Kaggle there are three categories. Okay, so you start as a so the categories are competitions expert, kernels expert, and discussion expert. Okay, so um, let me see if my profile is open. Uh, yeah. So for every you just join, when you sign up for Kaggle, you will get into you will get into 3 categories. So yeah, see, so for example, for me currently, I'm a discussion contributor, a kernels contributor, and a competitions expert. So what this means is like, say you share 10 kernels, and people upvote your kernels. So you get like a bronze medal, silver medal, or a gold medal, and you get ranking points, right? So there are and the same for discussion. Say you somebody was stuck in an algorithm, somebody didn't was stuck with a particular issue and didn't know how to proceed, and you provide an answer, and your answer gets upvotes, then you get different medals. So for example, um, I will. There was one algorithm for object detection, and I prepared a discussion for it, and then 8 people upvoted it, which is actually quite low. Um, and then you get so people are trying to I think it's a badge of honor to have become a kernels contributor and like a kernels expert and discussion expert, because you are just helping a lot of people. And I've started seeing people put um, like I'm a kernels grandmaster. Actually they have a couple of ratings, like they have different ratings, so you can that's their progression system. So you start as a novice, contributor, expert, master, and grandmaster. And I think right now there are maybe I saw was like maybe like 100 to 200 grandmasters across the world, like for each category. So there is a competitions, maybe 100 competitions grandmasters, 100 kernels grandmasters, and 100 discussion experts. And I'll show you the kind of detail that is shared in the when these in the discussions and the kernels. And basically it just shows so this page is just showing you what you need to be to get to the different stages. And you really have to put a lot of effort to move up. Okay. Let me show you. So uh, okay. So for every competition there are notebooks, and there is the discussion board. I find this extremely useful. um, and most of the times, even if I'm not actively participating in the competition, like maybe I have too much work and I can't um, like write code for it, I will follow the discussions, and they will you know because there will be a lot of discussions about people will tell you what they tried, what worked, what did not work. Okay. And so for example, um, let's look at one example. So this is not a kernel, but it's a detailed uh, discussion about what worked for this problem. So in this case, they used 2 types of models. One is called UNet, and I think we discussed it in one of the earlier sessions, in one of the earlier meetups. They tried UNet and MaskRCNN. Um, they will have a link to the many times they have a link to what is the paper they used. Um, and this is what I really like. They will tell you exactly like uh, what is the approach they tried. Um, okay, some details about what was the approach, what worked, um, uh, and okay. Many times people are very okay. So they tried this, and then okay, what was the next thing they tried? Okay, then okay, what was the second improvement, or what was the third improvement they tried? So I'll give you an example. I learned about TTA, which is the test time augmentations, from one of these discussions. So most of the time we are used to doing data augmentation during training. So we do rotations, flips, and rotation, flips, translations, whatever, right? Scaling during training. But I never thought of doing that during testing. Okay, so you take the same image, you apply your flips and rotations, and then um, get the output. And if your model is robust enough, you get the same output no matter what augmentation you did to the test data, right? So they tried it too, they just try to ensemble it. Let's say you have 8 copies of your test set, right? Or let's say you have a cat and you made 8 copies of it, and maybe five out of the 8 the output was cat, and maybe the 3 it was say dog or something else. So you're saying, okay, most likely it's a cat. Okay, so they said test time augmentation helped make them help give a consistent improvement. You want to say? And so now actually test time augmentation is such a useful feature. It is built into Fast.ai. It's available there. Maybe I stop here. Are there any questions? Okay. Yeah.
Yes, there were some questions on the chat. Some of them related to previous things. Let me go there. So there was a question about the full stack course that from Ronaldo, that the idea in the labs is to follow exactly the instructions in the lab. That is first from scratch and then use Keras or PyTorch. The reason I ask because we can cheat using Fast.ai and do it much easier, but that may defeat the purpose. So yeah, I guess I didn't go through those exercises. I'm not so sure myself, but I think they are more geared towards the full stack thing. They are not necessarily the best ML models, but they are good enough, and that's my understanding, that you can deploy them and build a whole pipeline for them. So I think that's the purpose.
Yeah.
So there was a question about Kaggle kernels. When you fork it, where does it show up for you later? Directly to GitHub or?
Good question.
Kaggle?
Okay. So it will show up in your own profile. So let me see. I think I can show you that. So you see, this is when you log in your account. I have 2 kernels. So these are, well, actually these are all of my kernels. And oh, I remember what the 2 is. The 2 is the 2 shows which are public, right? So for last time, I remember when we did the meetup. I shared this kernel, so it is public, and I put it on the Slack channel. And so anything with a lock is a private kernel. It's something I've just tried out, and yeah, see, I was getting used. I was starting with APIs, so I was like, okay, what? I was just playing with that stuff. This was the kernel that got the 10th place in the Kaggle Days competition. So that is shared. Yeah. So it will just show up in your account.
Yeah, so it's not linked to GitHub at all. It's complete different system. It's a Kaggle website, Kaggle system. Yeah.
Yes. Yeah. It's whatever internal they have, and like Mikhail said, you have version control, so that is just fantastic. So for example, for this kernel, I remember I have 3 versions, and you can look at all the history. So these are my versions, and you can even do like a diff, like between what happened between different kernels, what I changed. So even if I go back after 6 months or a year, I know exactly, okay, I can find exact, I won't remember anything, but I can look at the code, I can look at the diff and find what I changed.
Yep, thank you. Was another question about, is there any face recognition public kernel available? So maybe we can show how do you search kernels. Maybe that's the way to answer the question.
Sure. Yeah. So you just go to kernels and you can just do like, okay, let me just put face up one time. Yeah, and you basically get like a different bunch of kernels for face recognition. It's a little bit lesser than I thought, but maybe okay. There's like Yeah, and where is he getting? And the nice thing is the data set is there, and it has five celebrities, like 14 to 20 photos of these people. Yeah, or what? Yeah. So you can start with this, and what are they using? They're just doing just checking what is available, and come on, that's this not a good kernel. Like they just where's the model? Normally they can make sections so you can jump to the model, and I don't have to scroll through everything like this. Um, okay, okay, yeah, that's the what I can't see what model they're using. One. Yeah, just some. Uh, okay. So they're using support vector, I think support vector classifiers, and this is why I like these kernels so much. So I did not know this make pipeline feature exists. So most of the times you're doing data machine learning, you are putting like blocks together, right? So in this case, they want to do PCA and do support vector machine. So you can do make pipeline and just add your different blocks. Um, and I have something similar in my other kernel for Kaggle days too. You can just stack steps together, um, and then run yeah, and then combine the uh, like your model and do some grid search together. Yeah. Okay, that was kernel. So one last before I just go to object detection, I'll just show you.
We have a couple more questions, if that's okay.
Yeah, sure.
Yeah, so we have so we have comment that was strange name for me also when I started. I think that relates to kernels. It shows as a notebook in your account. So if you go back to that kernel you showed, Mehul, it shows an
sorry.
So you can see, yeah.
Okay, I'll just find mine and just share. Okay, so this one.
Any other, just one of them. Yeah.
Okay.
Yeah, on the left, it shows as a notebook. Mm-hmm. So the reason for that is so maybe if you try create a new kernel, then we can show that you have choice of creating either. So just create a new one, just for now.
Okay.
I think if you go to kernels and then new kernel.
Okay. Yeah.
And then you can choose either you can create a notebook style kernel, or you can just create a script style kernel. So that's the kind of, and both of those you can do in Python or R. So that's the kind of options you have.
Yeah, that's a good.
So that's why it says notebook on some of them. If you create script, then it will be different.
Okay. See what.
And then there's some explanation why they chose name kernel, and there's some links to the blog post.
Oh, I see.
About why they chose name kernel. So that's in the chat as well. And there's a question about the different GPUs used in the Colab, which is T4, and then P100, which is used in Kaggle, and which one is more powerful?
Oh, what was the Colab? I think here it's in the kernels it's the 100, right?
Yeah. I think T4 will be more powerful, but I'm not so sure. Maybe some searching.
I know. Like recently, in the Colab notebooks, there is a GPU, and there is also a TPU now. So I think Google is trying to popularize the TPU, so you can even use a TPU, and you will see some searches that the TPU might be a little faster, but I haven't played with it a lot. Yeah. But it's a little bit more painful to start off. Like Mikhail said, you have to do the work with your data. So you have to like maybe put it in Google Drive and get it from there, or figure out how you're going to get your data in the kernel. and in the Google Colab. Yeah.
Yes, I'm just reading online. Tesla T4 has got 16 gigabyte memory.
Oh, wow. Okay.
And it's a professional grade, launched September 2018, built on 12mm process. So how does it, it's on Turing architecture. How does it compare to P100? This doesn't explain this post, but 100 GPU. Just quick search. What does it tell us? It's also Tesla P100, so must be the same architecture, I believe. But what is so different about it? P100's got it's got either 16 or 12 gigabytes. I'm not sure which version they use in, but they look similar actually. Right, there was a comment about the face recognition that once Google released FaceNet, this seems to be the standard way of doing it. So that's kind of answering the previous question. There's one question: how do you get medals for discussion and kernels upvotes?
Yeah. So if you if you write a good so for example, this is let me show you this one. This one was so this guy for discussion, you just write a discussion thread, and so after the competition is over, normally all the top the top 10 teams, especially if they win money, they are supposed to release they are supposed to say how they did it and what was their approach. So they will most often release their GitHub, and in the discussions they will say exactly what they did. So for example, this is the person who won the biggest competition last year is Selim. He's a grandmaster, and he wrote a really nice blog. So if you see here, he's talking about okay, what was the loss function. So they combined cross entropy and soft dice loss. I never thought of doing that, before. They tried various various architectures. They tried at that time there were these two segmentation models, and maybe UNet and mask CNN. So in that competition, most of the teams were trying these two approaches, and mask RCNN is newer from Facebook in 2017. So people thought it might do better, but it turned out they actually did UNet with some modifications, and they did better. So you see, like in this blog post, they put their images, and they were segmenting cell. So it's an this is their output, and you can see it's just like if you write a really good discussion blog and people find it useful, people will find it, right? Um, they will find it. They will find your kernel, like how, uh, and so based on that you will get ratings, and you will move up the leaderboard. It's just a lot of time. So with I at Kaggle days, there was this one person. He said he was in the finance industry. He got bored. He just quit his job and he does Kaggle all day. But it's impossible to make money, or I can tell you that there's just so many people on it working right now. Um, I mainly just using as a learning platform, like learning practical things, learning new ideas.
Yeah.
Yep.
Thank you. We have more questions, so maybe we'll we'll go through questions if that's okay.
Okay. Yeah.
So there's a question about what's a private leaderboard. So each competition will have like 2 leaderboards. Maybe we
Yes.
talk about this. Thank you.
Okay, I'll talk about that. So initially, so when they each competition, right? The public leaderboard is they give you only like say 50% of the data. Okay, shoot, which one did I show? This one, yeah. Leaderboard, yeah. So there are. So what they started finding out is if I give you all the data, people figured out ways to cheat. So they will try to, let's say you're doing classification of animals, right? People will go and hand label things because there is some significant prize money, like whatever it is. So the thing they started doing is, initially when you're developing the model, so in this case the public leaderboard, they only gave us 1% of the test data, and they oh, okay, so you have okay, you have a training set and a test set, right? Let's say my test set has 10,000 images, okay. And you, on the test set, you submit your results and you submit the CSV file, but this score is only computed on 1% of that 10,000 data. Okay, so that's the public leaderboard. In this case, it's very small. Sometimes it's like 20% or 30%, and the main reason is to avoid cheating, and yeah, is for cheating. And then when the competition runs for 3 months, and when the competition is over, they will release the results on the entire test data set. Okay, so you already submitted it before, right? And you submitted your results of 10,000, and say you're trying different models, and for example, let me see where are my submissions? Yeah, okay. So in this competition, it ran over 3 months. So me and my teammate, we actually did 175 submissions. Okay, so we are trying different models, we are trying different things, and you can see the public score and the private score. So that's the um, public leaderboard score and the private leaderboard score. Um, and it basically you can see it's very interesting. It's like you will see people are doing really well on the public score, but when the final private leaderboard score is released, this okay, look at the top 10. Okay, these are the top 10 here, and when I go to the private, it's completely different set of people. So mostly what happened is those people might have overfitted on that because you are only seeing the score on that 1% or 10% of data. So you're trying to make modifications to your model, and you may be overfitting. Okay, that's it. Yeah, that's the private and public leaderboard.
So you have the delta to public. So so you have position on the left. And
exactly.
Delta to public. So the guys that won on a public, they were 173 position. So they jumped 173 positions to the top.
Right.
So that's the difference for them between public and private. So you have to find out a way to kind of generalize better, rather than to overfit to the public leaderboard. That's the kind of. Yeah.
So the question for me is what's important for the company, the public leaderboard or the private leaderboard?
No, the private, yeah.
Private,
because because the public is only on like 10% of the test data. So okay. The private is on the entire test data. Yeah.
Okay, thank you. So then there was a link to the GitHub repo with the FaceNet. So thanks for that. It's in the chat. It's question which Kaggle data, but I'm not sure what the question relates to that. So that GitHub repo is someone says great resource, pre-trained models. You can send the same repo to retrain model data. And then there's another GitHub repo with the face recognition. So check the chat that we're going to post after the meetup in the Slack. Another resource for the face, key point detection. So thank you for that. Then we have the comparison of the T4 and P100. So maybe we can check that quickly.
Okay.
And see what's better. So what's the score? So seems like the Tesla is green and P100 is blue. Seems like, depends on what you are testing it for. Seems like Tesla P100 is a bit better. Yeah, seems like Tesla P100 is better, faster. Okay,
And yeah,
I didn't
and
know that.
it's incredible that the P100 is free. I think in my company we use Amazon Web Services, and if we want to use a P100, I believe it's like $3 an hour. So it's a pretty, it's pretty expensive on Amazon, and it's incredible we have this free resource through Kaggle kernels. Yeah.
Yeah, for sure. There's a question about that some people use GitHub rather than Kaggle kernels, and is it so because it's more visible and more searchable outside of Kaggle?
Well, you could make your I mean, it just depends on your personal choice. Here it's, um, here if you look at the, uh, you can publicize your kernels. Like maybe I've seen people put links to their kernels on their GitHub pages or on their web pages. It's just a preference thing. Like, so for example, like see this kernel is so good, it has like 4,000 upwards, and I mean if I had a kernel like that, I would definitely put it on my resume.
Yeah. Then we have explanation about, again, public and private leaderboard, comparing that to train test cycle. So thanks for that. And I'll also be in a chat. And then there's a question, when does the model get training using the entire data for the private leaderboard?
It's always so initially you have the whole test data set, but they're computing the metric. Let's say they're computing accuracy. So in the public leaderboard, you only see the accuracy for 10% of your data. So they have it on their side in the back end, but they don't release it to you till the competition is over.
Thank you. And that's explained as well. Never, the test data does not have labels, but in real life you will retrain with the whole data set before deployment. So question, so basically private leaderboard equals rank.
Yeah, private leaderboard equals your final rank. Yes.
Excellent, thank you. So that's all the questions from the chat. So we have 7 minutes left. I don't think that's enough time for you, Mehul, to show us your object detection. So maybe we could. Sorry about that.
No problem. I can just show you one
maybe
web
we
page.
can move that to next week if you're okay with that.
Yeah, that's fine. Yeah, and this is the okay. Yeah, we can move it to next week. But basically, this is the introduction. It's like you have classification. Like there is a balloon in the image, or okay, which are the balloon pixels? Can you put a box around the balloon? And can you segment individual balloons? Yeah, that's the intro.
So I have a further question regarding the whole Kaggle introduction by Mehul. I recently had to dig into the Rossmann store sales competition. I don't know if you're aware of that, but that's basically a time series model that you should build predicting the store sales of this Rossmann store, which is a convenience store in Germany.
Okay.
And the first thing that I realized, so the evaluation metric that you alluded to was the root mean square percentage error. So people can look it up if they want to. It's basically, you can think of it something related to or closer to a mean squared error. And my question is the following. So actually, I have a couple of questions regarding this competition. First of all, where could one find a quick overview? The first thing that I wanted to do is I wanted to know what type of training data was available and what type of test data was available, in the sense that I wanted to see which years actually were available. And if I click on data, there's overview and then data. And then the data is described. That's good so far. But I wanted to have sort of like a short and very short description. What timestamps did they have into it? I had to actually look up a couple of papers and Google stuff such that I found out that the data is from 2010 to 2015, which I'm already not sure. Someone might look the data set, but you can already see it's not nicely described. Then the second question that I have, that the competition is over. The prize money was $35,000. And it's quite nice. Okay, I can understand they have their test bed that they don't release and so on, and there they test it. But the thing that the question that I have is, now we have 2019, right? Who says that this model still works? I mean, it's all based on this ceteris paribus assumption, that is, that everything basically more or less stays equal in terms of seasonality and so on. But there is no guarantee that this is the case, really. I mean, the ideal way how you would do this is you would use the winning model and then retrain it basically with the updated data that you have from every year, right? So you wouldn't use the predictions, let's say, if the model makes the predictions for 2015. You wouldn't use it for 2019. That would actually, in my humble opinion, be not an optimal solution.
No, I think you're right. Like one of the questions that Kaggle days was like, we have all these models, and how many of them are getting into production? And no one had an answer, right?
Yeah.
And mostly, I think like for me, I just use it for learning. And you're right. Like, okay, how do you need to update these models and like get more data? But so, for example, this company which did this thing, they haven't followed up. So,
Yeah, because the thing is also, I mean, the evaluation metric, the root mean square percentage error, of course it's a nice thing. And you can say one model is better than the other. I agree with that. But you don't really have a good metric for your what you want to do, namely predict, for example, in the sales in 2021. I mean,
right.
You can just say the model of Team A is better than the model of Team B, and I can see why. But it's not really. You cannot really give a statistical measure of uncertainty that you have for your prediction for, let's say, in the year of 2021. I mean, that's something I didn't understand. By the way, I'm not an expert in time series, but I just wanted to bring that up. A couple of questions that I had while looking this up.
I think for active competitions, they actually do that. You train on one set of data, and then they go and look at the future data. I think there is a 2 sigma competition that's either over or about to be over. So initially people train on the data, and then whoever scored enough, like now the kernels are using like latest data, like that was collected
that makes sense. That makes sense. Thank you very much. That's exactly how I would do it. Yeah, that makes perfect sense.
Yeah, this is the prediction of the stock prices, I think. So they logged models like 2 months ago, and now they're testing for like months. And I think they're going to choose a winner based on that. I think that's quite unique in terms of Kaggle. There's not that many of those.
Yeah, Mikhail is right. Yeah, this is a very unique competition. They locked it, and now in last 2-3 months they're just looking at how it does in real data. Description. Maybe. Yeah, I know for the data science bowl, like in the segmentation of cells, it's a really hard problem for biologists. Like so most of the other parts are automated, like taking images of the cells is automated, but then doing the actual segmentation of the nucleus was very hard. So that there were a lot of ideas from that competition, but I don't know how many. I think that's one missing piece. We don't know how many go into like, okay, how many went into a paper, or how many went into their real life. would be nice if we had that follow-up. But I learned a lot. Like I did 2 competitions, and everything I know about object detection I learned from here.
Yeah, sure. I mean, the criticism that I just brought up is also kind of specific to time series, if you think of it. It makes a lot more sense in classification problems that you just alluded to there. The whole complexity of this ceteris paribus assumption is way more relaxed than in say time series. I mean, that's also very specific. It's a huge difference if you want to detect an object in a picture, or whether you want to predict the sales in a certain year, or you have to incorporate a lot of domain expertise about, say, seasonality. For example, you could immediately assume that if the temperature goes up, then the sales of certain ice creams would go up, because the demand for ice cream is highly dependent on the temperature outside, because if it's warmer, then people tend to eat more ice cream and so on. So that's these models, I guess that's what I'm saying, is the classification problems are more, the whole assumptions that lie behind that are easier and better than the whole sales prediction of the Rossmann stores. Because you can also, I mean, you can generalize if you test it on your test set, and then you can say this assumption pretty much holds. If I'm right in my test set in let's say 95 out of 100 cases, then you can be pretty sure that if the sample is representative, then you can be pretty sure that your system is actually pretty good. So yeah.
I think that the Rossmann example was also discussed during the Fast.ai course by Jeremy. So basically, they give you all the data with all whatever dates, and because that's time specific, the time series kind of like date, it is time series data. So the first thing Jeremy kind of suggests to do for that kind of data, pick your last, I don't know, 2 months or 2 weeks as your validation data, because you're going to treat that data as unknown to your model, and you're going to use the past data and your future data, well, kind of future for your model. You know that future, but your model doesn't know it, and then you try to use it. So other situation, you may use like the cross-validation technique when you pick like random.
But can you do that? I've read that it's actually fairly hard with time series data, because you basically do auto regression, and that means that you cannot randomly shuffle, basically.
Yeah, exactly. So that's not recommended, indeed. So the recommended way by Jeremy is to pick the last, whatever, 2 weeks, 2 months, the last data points, and use that as your validation. That's correct, yeah. Okay, excellent. Do we have any more questions? That sounds like no. So we're going to start next week with the full stack deep learning. So if we can watch lecture 1, 2, and 3, and the lecture 3 is actually the lab 1 and 2, and try to play with the GitHub code, and then we can have a discussion about it next week. And also for next week, we had another presentation scheduled by Mehul about object detection, so we're going to move that to next week. And also we had deployment of deep learning models presentation scheduled, if this is still in the agenda, so we'll try to confirm that later. So, okay, that's great. So thank you for today, and see you next week.
Thanks, Michael, for hosting.
Thank you.
Thank you.